We are taking this from the September 2014 from the Eastern Cape. Question 9. A learner wants to use a battery with an EMF of 13 volts to operate a walking door. The battery has an unknown internal resistance of R. The walking doll has a resistance of 6 ohms. The learner uses the circuit below to obtain the potential difference required for the walking doll to function. When switch S is closed, the reading on the voltmeter drops to 12 volts and the walking doll functions at its maximum power of 6 watts. Let us analyze the circuit diagram. So we will look for the positive part of the battery. The longer arm is the positive part of the battery. So this is longer than that one. So this side will be positive and that other side will be negative. The current flows from the positive terminal of the battery. So this is I total. And then when it gets to that junction right there, the current is going to be divided. So here we will have I1 and then down through R we will have I2. Since the current is divided at that point, it means that R and the 6 ohm are connected in parallel because resistors in parallel are current dividers, but they will have the same potential difference. At that point there, I1 and I2 are going to combine to form I total again. And then the 2 ohm and the 1 ohm resistors are connected in series. Resistors in series are potential dividers, but the current should be the same. So the total current will flow through the 2 ohm as well as the 1 ohm resistor. And then the total current will flow back into the battery. 9.1. Explain briefly why the reading on the voltmeter drops when switch S is closed. So, due to the internal resistance, so the reason why the voltmeter drops it is because due to the internal resistance which must be overcome in order for current to flow. 9.2. Calculate the internal resistance R of the battery. Show all the steps in your calculation. We have this formula. I R multiplied by R. So this can be written in three different forms. We can distribute the current into the bracket. So we'll have that. And then IR, this is the V external. And then I multiplied by the small r, the internal resistance. This gives us the V lost. So currently we have the EMF and the V external, because remember, when switch S is closed, the reading on the voltmeter drops to 12. So it means that the voltage that's being supplied to the external circuit must be 12 volts. So the EMF is 30 and V external is 12 plus V lost. So it means that V lost should be equals to 1 volt. But we know that V lost is I multiplied by R. So we need to find the total current in order for us to be able to find the internal resistance. So in order to find this, we need to find that because we already have the V lost. Okay, let's look at the circuit. So R and the 6 ohm dial are connected in parallel. And then we know that for a parallel combination, the potential difference should be the same. However, the current will be divided. And then we have the power as well as the resistance. So the power is 6, and then the voltage we don't know, and the resistance is 6 as well. Therefore, the voltage should be 6 volts. So this is for the parallel combination. So if we were to combine the 6 ohm and the R, we'll have something like this. So this will be R parallel, and this will be the 2 ohm, and then that will be the 1 ohm resistor. So now we have the voltage that's flowing through the R parallel. We do have it's 6 volts. So for these two, they are connected in series, so they will have the same current. However, the voltage will be divided. So we should combine these two and make them one resistor so that they have the same voltage. So R series should be equals to so here I'm going to have a 1 plus 2, which is equals to 3 ohms. And then I know that the external voltage should be the voltage through the parallel combination plus the voltage across the series. V external is 12, and then V parallel is 6. So the V series should be equals to 6 volts. Because I know that the external voltage that is supplied to the external circuit must be equals to 12. So if the voltage that is supplied to the R parallel is 6, and then the remaining voltage should be 6 as well, so that I get a 12. So I total should be equals to V series all over R. So the V series is 6, and then the series I also have, it's 3. Okay, so the total current is 2 amperes. So V lost should be equals to I total multiplied by the internal resistance. So the V lost is 1 volt. Total current is 2, and then the internal resistance. So this is equals to 1 over 2, which is 0.5 ohms. 9.3. Calculate the magnitude of the unknown resistor R. The R is connected in parallel with the dial. So let me find R parallel. So we take the first resistor, multiply it with the second one, and then we find the sum. So that is the parallel combination. And then I know that when I combine these two, the total current will flow through that 1 ohm resistor, because when you combine the two of them, they become one resistor. So this is going to be I V all over R. The total current should be 2, and then V parallel I've already calculated, and it was 6. So I know that this will be a 6, and then the resistance will be 6R all over 6 plus R. So this is 12R 36 plus 6R should be equals to 6 ohms. The resistor R is replaced with a conducting wire of negligible resistance. What effect will this have on the V lost? Fully explain your answer. Okay, let's just clean up our sketch. Okay, so we are killing that resistor right there, and then we are connecting a wire of negligible resistance. So a conducting wire has zero resistance, thus will allow maximum current to flow through it. So it means that the maximum current will flow across the wire. So in this direction, no current will flow because the current always flows in the path with the least resistance. So zero current will flow this way. So it means that we are also killing that resistor there. So if we kill two resistors that are in parallel, it means that the R external will decrease. We can even check. So let's check R external. This was before we killed R. So R external should be equals to R parallel plus R series. Remember, R parallel is given by that. So it's 6 multiplied by 6 all over 6 plus 6. And then the R series is just 3. So this is a plus. So here I'm getting a 6 ohm. So this is before we kill R, and then this is after. After we have removed R, so R external just becomes 3 ohms. You don't have to do the calculations. If you know your theory and understand it, then you'll be able to get the answers easily. So R external decreases. So the current increases. And again, these two are from I should be equals to V all over R from Ohm's law. So we know that I is inversely proportional to R. So when you increase the resistance, the current should decrease. So current increases. And then from this formula, we know that I multiplied by R plus IR is equals to V external plus V lost. So when you increase the current, the whole product goes up. So V lost goes up. And since the EMF doesn't change, the V external is obliged to decrease. So this will decrease. So